Hey everyone, let's try to solve the Gymnasium taxi environment today. Let me hop over to my code. I am in my Gym Solutions folder. I make this available in my GitHub page. The link is in my description. I'm literally going to grab the Frozen Lake source code from my Frozen Lake video. I'm hitting Ctrl-C to copy it and Ctrl-V to make a copy of it. Let me rename this file Taxi-Q. And we're just going to use regular Q-learning to solve the taxi environment. Now, all I need to change is the environment. The map size and slippery flag doesn't apply. Let me get rid of it. And I'm just going to rename the things that are referencing Frozen Lake. And rename it taxi. Some of these comments might not make sense for taxi, but I'll correct them later. Now let me go down to my main and I'll just train it for 15,000 that it has here already. And then I'll run it for 10 times as a test. So I just hit F5. In about a minute, it should be done. Okay, it's done. And you can see that the taxi is going to pick up the passenger and taking them back to their apartment. Okay, let me slow this down so we can see what's going on. In each episode, the taxi starts off in a random position. The passenger also appears in one of the random color squares. The apartment building or the destination also appears in one of the color squares. In a moment, we're going to see the taxi pick up the passenger. Now the taxi is going to take the passenger to the apartment building. Okay, now let's talk about why it works. I have a screenshot of the taxi on my whiteboard. So with Q-learning, we're essentially trying to create a Q table of states and actions. Now looking at the environment, the action space is 6 and the observation space is 500. So we're expecting to have a 500 by 6 table where this is going to be going from 0 to 5 and this is going all the way to 499. So what does these numbers represent? Let's scroll down. The action space, 0 is to move down, up, right, left, 4 is pick up passenger, 5 is drop off. So this represents down. Taxi picking up, dropping off the person. Now, what about the states? The taxi can have 25 possible locations. So this is actually a 5 by 5 grid. So if you can imagine a grid, the taxi, I'll write it down here, is a 5 by 5 grid, so it could take on any one of those 25 positions. The passenger has 5 possible locations, which is listed here. It could be in one of those color squares, or it could be in the taxi. If the passenger is in the red square, it would be represented by 0, and then 1 if it's in the green, 2, and 3. And if it's inside the taxi, then it's a 4. Passenger has 4 colors, and if it's inside the taxi, so it has 5 possibilities. Finally, the destination could be any one of those color squares. So this apartment building can also randomly show up in one of these color squares. If we multiply all of these together, 25 times 5 times 4 is 500. So that's how they got the states, and they gave us a formula to convert those numbers into a single number. So it's going to convert the coordinate, the location of the passenger, and the destination into a single number. Having a single number is optimal for compute, but if we have to do debugging, having the single number, for example, if it's in state 377, I have no idea where the taxi is, where the passenger is, or where the destination is. So alternatively, we could do this. We can have the X location of the taxi, the Y location of the taxi, the state of the passenger, state of the destination. So instead of having a 2x2 array, we would have a 4x1 array. So I like to do it this way to make the queue table more easier to read and troubleshoot. But since the code is working, I'm not going to mess with it. But just keep in mind that you can encode the state just like this. Now let's take a look at the reward system. Basically, every step that the taxi is taking, it's getting penalized by -1. If it does pick up or drop off, that doesn't make sense. There's no passenger to pick up or it's not at the destination. It would be an illegal move, so it gets a penalty of -10. And if it's able to pick up the passenger and take the passenger to the destination successfully, it gets a +20. The episode terminates when the taxi drops off the passenger. Now let's walk through an example. So my taxi is over here. My state is gonna be, it's at 1, 1. And my passenger is at 0. And the destination is 1. So this represents the current state. We can send this through the formula to produce a single-digit representation, but for the demo, this would be much easier to follow. Now in this state, it's easy to tell that if the taxi heads in any other direction, it's just going to incur a lot of penalty. So eventually, through random exploration, it's gonna know that going up or going to the left is going to be the best actions. So in the queue table, we can expect that the up action and the left action is going to get a high Q value. And I'm just putting in 0.9 here to illustrate. Let's say the taxi went up here. So now the taxi is in state 1001. In this state, eventually, through queue learning, it's going to figure out that going left is the best action. So I would expect that in this state, this is probably going to be a 0.8. And once the taxi is here, which is 0001, performing any other action is going to incur penalty. So eventually it's going to figure out that picking up the passenger is the best action to do right here. I'll put a 0.7 here. Now let me erase this. Okay, we just picked up the passenger. Now after picking up the passenger, our taxi is still at 00. Now the passenger is in state 4. Since now it's sitting inside the taxi, our destination remains the same. And in this state, there's really only two actions that make sense, either right or down. Let me throw a 0.6 here and to the right. Now let me draw out the shortest path in terms of penalty. If it goes this way, it incurs -1, goes down -1. When it goes here, it's -2. Now following the sequence of numbers, you can see that there are several possible paths to the apartment building. And once the taxi reaches the apartment building, it's going to figure out that the best move is to drop off the passenger, which gives a +20. So +20 -8 is going to be a score of 12 here, or a reward of 12 here. Similar to how the taxi found the passenger at the beginning, the taxi is going to find the apartment building in a similar way. Okay, I'm going to end the example here, but I encourage you to grab my code from my GitHub page and try this out. I hope this was helpful to you. Don't forget to like, subscribe, and drop me a comment if you have any questions. Catch you next time.